Good afternoon, ladies and gentlemen. I am Fuada, a researcher from ITB Indonesia. Thank you so much delivered to Professor Yin Ho Chung as a chairman of this special session for the opportunity to present by video because we cannot attend the conference. Actually, we have two papers for NOLTA 2017 in which you can find in my YouTube account. Okay, so the second paper of us is entitled Optical Interference Noise Filtering over Visible Light Communication Systems Utilizing Analog High-Pass Filter Circuit. Okay, well, ladies and gentlemen, our presentation is divided into 5 sections, that is introduction, experimental setup, results and analysis, video demonstration, and the last is the conclusion. The background of this paper is, exactly, we have observed in our previous research in the investigation of ambient light effect, that the LED not only transmits the information signal but also carrying DC signal. This DC component needs to be eliminated because it can make the information signal clipped, saturation in receiver op-amp. On the other hand, the interference lamps are not only carrying DC signal but also carrier signal with 100 Hz of noise frequency. The shorter the distance of the photodiode to the interference lamp, the larger the DC component and the amplitude of noise. The signal which is carried by the DC lamp and also interference lamp must be eliminated because it can increase the bit error rate which can degrade the VLC system performances. The motivation in this paper is to design a high-pass filter to reduce the signal interferences from incandescent and fluorescent, which is said to be static at a certain distance. Thus, the VLC system is sufficient from interference lamp as well as ambient light noises. Ladies and gentlemen, in this slide, we can see the DC offset remover circuit and its implementation, then the analog high-pass filter circuit and its realization into double-layer PCB. In this slide, we show the simulation and the experiments results of high-pass filters. It shows that frequency below 150 Hz can be attenuated, which proves the designed analog filter by the simulation and real implementation is able to work properly as designed. This slide shows the results of incandescent lamp filtering in time domain using oscilloscope and frequency domain using frequency analyzer. It is proven that the noise from incandescent can be reduced. This slide shows the results of fluorescent lamp filtering. We can see that the carrier frequency with 100 Hz can be eliminated. In this presentation, we also demonstrate the robust VLC against interference lamp. The VLC demo has been done by our laboratory member. The conclusion of this work is the analog filter can reduce the frequency under 150 Hz, which is the carrier frequency of the incandescent and fluorescent lamp, and the DC offset remover, which uses the summing amplifier configuration, is able to eliminate the DC signal from the ambient light. And finally, thank you so much for your attention. If any question, you can contact the email below.